Hey folks, welcome back. In this video we're going to go over one worked example to show you how to do problems involving the bubble chamber as our first application of fields. Now if you haven't already done so, check out my previous video covering the theory on this topic, and that way you can apply what you learned in that video to this one. So let's get started. So in our one and only question it says inside a bubble chamber a proton is injected at right angles to the direction of the magnetic field of magnetic induction 0.28 Tesla. The kinetic energy of the proton is 4.2 times 10 to the minus 12 joules. Part A says to calculate the radius of the circular path taken by the proton. But what we want to do here is first use the kinetic energy to find the speed of the proton. So doing that, we're trying to find V. We know that the mass m of a proton is 1.673 times 10 to the minus 27 kilograms from the datasheet. We know the kinetic energy here is 4.2 times 10 to the minus 12 joules, and so writing down our equation for kinetic energy, we have Ek equals a half mv squared. Substituting in the numbers gives 4.2 times 10 to the minus 12 equals a half times 1.673 times 10 to the minus 27 times v squared. And so doing the left hand side divided by a half times the mass of the proton will give you a value for v squared of 5.0 times 10 to the 15. And then to find v on its own we want to square root both sides, so we get v equals 7.1 times 10 to the 7 meters per second. So we now have the speed of the proton, but we want to calculate the radius, remember. So we can then say the magnetic force provides a centripetal force here. So we could equate the magnetic force to the centripetal force and say that QVB equals mv squared over r, where this is the form of centripetal force in terms of linear velocity since we just calculated that. Now you can either just substitute the numbers in at this stage, or you can rearrange for r first of all. So if we rearrange for r, it's the same as just swapping the r in the QVB term round, so we get r equals mv squared over QVB, and then you'll notice that we can cancel a v from the top and bottom here, so we end up with r equals mv over qb. Substituting in the numbers gives 1.673 times 10 to the minus 27 times 7.1 times 10 to the 7 divided by 1.6 times 10 to the minus 19 times 0.28, and if you put that into your calculator you should get an answer of 2.65 meters. Lastly, part B says an electron enters the magnetic field at the same speed and angle as the proton. State two differences in the path of the electron compared to the path of the proton. Justify your answers. Well, we could say that the electron will travel in the opposite direction to the proton since it has the opposite charge to a proton. And we could also say the electron's circular path will have a smaller radius since the mass of an electron is smaller than the mass of a proton. And from our equation that we just derived, r equals mv over qb, we have that radius is directly proportional to mass. So a smaller mass for the electron will mean a smaller radius. That's all for this video folks, thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a like, subscribe to the channel, and I'll see you in the next one. Take care.